So let's go ahead and try one more example here. So cylindrical shells, we have the function y equals x plus 3 over x, y equals 10. We want to rotate about the line x equals 12. Okay, let's see what we've got here. All right. Well, let's see. As far as the graphing is concerned, now you can use your graphing calculator, or you can use any graphical tool that you can find on the internet. You can go ahead and express this as a rational function and use the techniques of differential calculus to graph it. Suffice it to say that y equals 10, so we're looking at that. The graph itself actually looks like this. Look, goes down and it comes up like that. So whatever technique that you need to use in order to graph it, that's what the graph of this looks like. Now y equals 10, that's this line right here, so that's y equals 10. So this is the region that we're concerned about. Now it's this region that we're going to be rotating. They say rotate around the line x equals 12. Well, it turns out that x equals 12 is actually right about there. So this is 12, therefore our region is going to be something like that. Maybe a little, probably draw it a little bit better than that. It's going to come down to about right there. So something like that. So this is the solid that we're dealing with. So our axis of rotation is 12, which means that our representative shell is going to be, the sides of the shell are going to be parallel. Okay? So when we measure r and h, r, again, we're measuring from the axis of rotation to the original function. That's r. That's h. R is equal to, well, r is equal to this length, 12, minus this length, which is x. So it's 12 minus x. Height, well, the height is 10 minus f of x. It's this height minus that height. So it's 10 minus f of x, which equals 10 minus x minus 3 over x. Okay, now we need the a and b. So we have our r, we have our h, which is this thing. Now the question is, what are a and b? What are a and b? Well, I'm going to integrate from where the two graphs meet, the x value, this one and this one. So, where do the two graphs meet? Well, just set them equal to each other. So x plus 3 over x equals 10, and solve. So we get, so let's do x plus 3 over x plus 10. X plus 3 over x equals 10, which gives us x plus 3 over x minus, let's get this right, 3 over x minus 10 is equal to 0. So we're going to get x squared plus 3 minus 10x equals 0. So we have x squared minus 10x plus 3 equals 0. This is a quadratic. When I solve this, I get x equals 0.31, and I get x equals 9.69. So I'm going to be integrating from 0.31 to 9.69. So my volume is equal to the integral from a to b 2 pi r h dx. The integral from 0.31 to 9.69 to pi. My radius, we said, was 12 minus x. Our function, our h, our height, was 10 minus x minus 3 over x, and we're integrating along dx. Plug this into your calculator. This is going to be one of those situations where you're definitely going to need a calculator. And my final answer for volume is going to be 2 pi times 301.29, and that is all. The important thing is coming up with this. Okay, thank you so much for joining us here at Educator.com. We'll see you next time. Bye-bye.